Drive configurations. Minus redundant array of independent disks, RAID 0, 1, 5, 6, 10. To ensure your text-to-speech reader handles this smoothly, I have removed the visual table and converted that data into a clear, spoken-word summary. Think of RAID, the redundant array of independent disks, as the engineering solution to three problems: capacity, performance, and uptime. In your cybersecurity home lab in NYC, you are running a powerful Intel i7 system. But if your storage isn't configured correctly, it becomes a massive bottleneck. By the time you finish your degrees, you will likely be managing these arrays in a government data center where a broken drive cannot mean a broken network. The fundamental philosophy: striping, mirroring, and parity. Before we dive into the specific levels, you must internalize the three building blocks of RAID. Every level we discuss is just a different combination of these three concepts. Striping, this is the performance block. It takes a file and chops it into segments, sending those segments to different drives simultaneously. It's like having multiple mail carriers delivering parts of a single package to different doors at the same time. It is much faster than one carrier making several separate trips. Mirroring, this is the redundancy block. It creates a perfect, real-time clone of your data on a second drive. If the first drive fails, the second one is already there, identical and ready to take over. Parity, this is the mathematical block. Instead of cloning the data, the RAID controller performs a logical calculation. It calculates a check bit. If a drive fails, the controller uses the remaining data plus that check bit to mathematically reconstruct the missing information. RAID 0, the speed demon. RAID 0 uses striping and nothing else. When you write data to a RAID 0 array, the controller splits it up. If you have two drives, block 1 goes to drive A, and block 2 goes to drive B. This effectively doubles your throughput, the amount of data you can move per second. The use case: in your lab, you might use RAID 0 for a scratch disk, a place to store temporary files while you are running an intense AI calculation where you don't care if the data is lost if a drive fails. The technician's warning. For the exam, remember that RAID 0 is the only level where a failure of any drive results in 100% data loss. Because of this, we often joke that the 0 in RAID 0 stands for how much data you will have left if a drive dies. RAID 1, the mirror of truth. RAID 1 is the most basic form of fault tolerance. If you have two drives, they are perfect twins. Every time you save a log file from your cybersecurity tools, it is written to both disks. The advantage: it is the simplest to recover from. If a drive fails, you just pull the dead one out and the system keeps running. There is no complex math to slow down the processor. The efficiency problem: RAID 1 is the most expensive in terms of storage. You lose 50% of your capacity. This is why we usually reserve RAID 1 for the operating system partition. It ensures the server always boots, even if a drive is dead. RAID 5, the king of the enterprise. RAID 5 is a brilliant engineering compromise. It uses striping with parity. To understand RAID 5, imagine you have three drives. Data is striped across them, but on every row, one block is reserved for parity. The controller rotates this parity data so that no single disk becomes a bottleneck. The math: if drive A holds a 5 and drive B holds a 2, the parity is 7. If drive B dies, the controller knows that 5 plus a missing number equals 7. It calculates that the missing data must be 2 and recreates it instantly. The capacity formula. For the A+ exam, remember this formula: the number of drives minus 1 multiplied by the capacity of the smallest drive. If you have 4 10-terabyte drives, you have 30 terabytes of usable space. You only lose one drive's worth of space for protection. Minimum drives: you must have at least 3 drives. RAID 6, the double failure safety net. As hard drives became massive, the time it takes to rebuild a RAID 5 array can take days. If a second drive fails during that rebuild, the RAID 5 array is lost. RAID 6 was created to solve this. RAID 6 uses double parity. It calculates two different types of mathematical checks and stores them on different disks. The benefit: it can survive the simultaneous failure of two drives. You could have two drives die on a Friday night, and the system will still be running perfectly when you walk in on Monday morning. The trade-off: the write performance is slower because the CPU has to do twice as much math. You also lose 2 drives worth of capacity. Minimum drives: you must have at least 4 drives. RAID 10, the high-performance hybrid. RAID 10 technical. RAID 1 plus 0 is a nested RAID. It combines the speed of RAID 0 with the safety of RAID 1. Think of it like this: you take 4 drives and create 2 pairs of mirrored bodyguards. Then, you stripe those 2 pairs together. The power: because there is no parity math, RAID 10 is the fastest performing redundant RAID level. It is the gold standard for high-intensity databases and AI workloads. The cost: like RAID 1, you lose 50% of your capacity. Minimum drives: you must have at least 4 drives. Implementation: hardware versus software RAID. As a technician, you have to decide where the brain of the RAID lies. Hardware RAID: you install a dedicated RAID controller card. This card has its own processor and its own dedicated memory. This is the professional choice. It offloads all the math from your main processor and usually includes a battery backup module to protect data during power outages. Software RAID: your operating system manages the drives. It is free, but it uses your computer's RAM and CPU to do the work. This is fine for a small home lab, but never for a high-traffic production server. The technician's maintenance checklist. When you are managing these arrays, you need to understand 3 professional terms. Hot swapping: the ability to pull a dead drive out and slide a new one in while the server is still running. Hot spare: a drive that is plugged in but asleep. If a drive fails, the controller automatically wakes up the hot spare and begins the rebuild process without you even touching it. Rebuild stress: when an array is rebuilding, it is under extreme stress. Every remaining drive is spinning at maximum speed. This is the most common time for a second drive to fail. Audio summary for the A+ exam. To lock this in for your exam, remember these 5 quick summaries. RAID 0 uses striping for speed. It has 0 redundancy and requires at least 2 drives. RAID 1 uses mirroring for redundancy. It has 100% data duplication and requires at least 2 drives. RAID 5 uses striping with parity. It can survive 1 drive failure and requires at least 3 drives. RAID 6 uses striping with double parity. It can survive 2 drive failures and requires at least 4 drives. RAID 10 is a stripe of mirrors. It provides high speed and high redundancy, but at the highest cost. It requires at least 4 drives. Final thought: RAID is not a backup. This is the most important lesson for your career. RAID protects you against hardware failure. It does not protect you against human error, ransomware, or disasters like fire or flood. Always keep a separate, off-site backup of your most important cybersecurity data.